Started. So what is this? Networking devices. The first thing is we will discuss about a different types of networking devices. In the last class, we started one by one, right? So here it is. Don't think like your Wi-Fi kind of stuff. It is first normal way I'm telling. Okay, guys, I have a devices and to connect these devices in a network, and these devices required. Very nice. These devices required NNIC. Okay, devices required NNIC. For example, I have a switch. There is a sockets, RJ45 sockets are there to the switch or a hub and to the our pieces. In a wide way of connectivity, I'm telling, in a wide way of connectivity. This is being big part. Okay. So what you will do? First, we need a NIC. So then we can able to connect it. If it is a wide way, the wide related like a Ethernet cards are required to connect. So I am connecting a wire from here to here. I am using a CAT cable, a CAT6 cable, a UTP cable. It is. I connected from my one device to this switch or a hub. Now it is. We created a network. We created a network. So these devices can able to communicate to them. And this is a networking device. It can be a hub or it can be a switch or it can be any other. But each device has their own purpose. To create a simple LAN, I can use hub device or a switch device. But I want to communicate outside of my network. Okay. Or how to communicate outside of my network. Then I have to connect it to the router. Router is internetworking device. So if I want to connect and communicate outside of my network, so I have to communicate it through a default gate. Okay. I want to connect. I want to communicate from A to B. I don't require this equipment. Only hub or switch is enough. But I want to communicate from C to some other device and it will communicate like you want to communicate google.com, youtube.com. You have to go through this one only. Okay. And from here, it has to be thing. Like for example, you want to communicate to the internet like a google.com, youtube.com, you want to reach it. So how can you reach? So that is in the internet. So you have to connect it to internet. To connect internet, so then you have to connect it to your modem. This is router and this is the modem. You have to connect it to modem. What is this modem will do? Modem make you connected to ISP, Internet Service Provider. Through this Internet Service Provider, you can able to communicate in the internet. In the internet. Okay. So you want to get connected to internet, you need a internet subscription, right? So you have to connect it to ISP. So then we can able to connect it to internet. So then we can able to access google.com, facebook.com, youtube.com kind of stuff. Okay. So then connectivity is from here to here and here to here, then here to here. Okay. So each device has their own purpose and way of functionality is there. Now we are going to looking into these devices and how it is works and what is their purpose. And here it is an important is hub, switches, router, modem. So I'm going to explain all these four devices, small information about a repeater. Okay. So a small introduction here only. Guys, hub is used for LAN communication and mainly used for a small network communications only. Means three, four devices you can connect. Can we connect it to the large network? We can connect. Will be a problems. Okay. Switch is used for same LAN communication only. Hub is LAN. Switch is also for LAN communication. But it is used for both small and large networks. It means there is a you can use it for a 10 computers, you can use it for a 100 computers also. That is a switch capacity. And switch has additionally MAC learning features are there, and switch use MAC tables. Switch create a MAC table. With the help of MAC table, it can able to make packets unicast. So that we will explain in the switch chapter. Just only highlighted points. The router used for LAN communication and WAN communication. LAN communications and WAN communication, or one side LAN, other side WAN, or one side LAN, other side also LAN. Okay, like that. We can make a communication between different networks. Router is make a communication between different network. That is a router purpose, not for just connecting devices. Router's main purpose is to make a communication between different networks. You can see this is your this is one network. Okay, this is another network. The router is make a communication between one network to another network. So that is the router function. It is internetworking device. Internetworking device means communication between different networks. It shows best path to reach the destination. How to reach google.com. I don't have google.com in my office, right? It is somewhere in this world. I don't know. Okay. But I can reach it. Okay. But there is a several paths to reach the destination. Which is the path is best path to reach the destination. That will given by the routers. Next device is modem. We can connect to the internet via ISP using telephone cables, fiber optical cables. We are connecting to the internet through the ISP. So first of all, you have to connect to the ISP from your modem. So then the ISP will take you to connected to the. Let's understand the basic points. No one is telling anything.
Yes.
Okay, sir. Thank you. Guys, this is hub. The hub is look like this. This is a D-Link company hub. If you see, there is almost all 8 ports are there in a hub. Hub and switches both are for LAN communication. Okay. When I underline this one, so read it carefully. It is used for LAN communication only. This hub is a device. It does not understand your packets, MAC address or IP address kind of stuff. It does not mind about anything. Okay, we are using for small networks. I will tell you why we should use for small networks also. Okay, as for OSA layers, the hub is comes under layer one physical layer. Again, what is hub will do? It broadcasts the packets to every device in the network. It broadcasts the packets to every device in the network. For example, here I'm using hub instead of switch. What will happen? This is my PCs are communicating each other. So here I am connecting these devices to a hub. Okay. For example, I want to communicate from A to B. Want to communicate from A to B. So packet is start from here. For example, I'm using a ping command, C A to B ping command, or maybe I'm sending a some message. So what happened? Packet is start from A and go to the hub to this particular port. From this port, it is given to these ports. All the ports where the devices are connected. To the devices disconnected. Okay. And packets are given to everyone, those who are connected to the hub. Okay. It broadcasts the packets to everyone connected to the hub. Everyone connected to the hub. So here in this one, C received a packet and dropped the packet. F received a packet and dropped the packet. E received a packet and dropped the packet. D received a packet and dropped the packet. B accept the packet. How it is? The destination address. C will check. C's device will check. Is a packet is for me? Check it and no, then it will drop the packet. A check. F also check same thing. Is it packet is for me? No, drop the packet. Like this. So here we have a six systems, just simply A to B communication only, but packet is went to all other devices. Not only to the B, it also went to the C, D, E, F also. So unnecessary traffic is generated, right? Unnecessary traffic is generated. Like this, at a time, the multiple devices are communicating each other. B to D communication is there. C to A communication is there. A to E communication is there. Or something like F to E communication is there. Okay. What happened? Multiple devices are communicating. What will happen? Lot of packets are generating and broadcasting. So lot of packets in this hub and devices we receiving its packet and as well as others packets also. Okay. B is receiving the packet which is from other devices which is not for meant for B also. Not only from A, also it is receiving from other devices packets also. So what happened? The path is entirely become busy. And this is complete traffic is generated and the packets are collide each other. Okay. So what is a hub? Hub is a broadcast packets to the device, every device in the network. Here A send a packet to B, A send a packet to B means A to hub, hub to B, C, D, E, F also. B accept a packet, remaining is drop the packet. And unnecessary lot of packets are send and receiving thing. So what happened? The packets are collided and packet data loss will occur with the hub. Okay, guys understand what is hub? Hub is a device used to in a LAN communication. We can use for small networks. Why? Because of the packets we are broadcasting to every device in the network. Okay, it broadcasts the packet to every device in the network. So because of these broadcasts, traffic is increases, collisions increases, packet data loss is also high. So if it is a small network, small number of systems, small lesser the traffic, less collisions, less packet traps. Okay, if it is a small, if you are using huge, so more number of devices increases, more devices will communicate each other, more traffic is generated, more collisions will occur, more packet damages occurs. Okay, that's why we are using for a small networks. Okay, it is used for LAN communication. It is layer one device as a OSL layer having 7 layers. Last 3 layers are hardware layers. The layer one device is an example for a layer one device is hub. Okay, someone is trying to ask a question. You can ask me, no problem. Guys, this is a Cisco packet tracer simulator. This is a kind of simulator. It helps to understand how it is communicating. Just I'm assigning an IP address. Without IP address, we can't communicate, right? So that's why I'm assigning an IP address. Okay. Now I want to connect these devices so then they will communicate each other. Okay. So how to connect each device? The devices like a computers are having a Ethernet card. See, like a card is there. So RJ45 socket is there. For this one, in the picture, it is having front side. In generally, it is in the back side. And this is the hub. Okay. Of course, it is having a 6 ports only. Okay. These are the different ports in this one. We can add it more because it's a PT type. And I'm connecting each one to like this. Okay. So look at this simulation. Guys, I'm sending a packet from this to this, from here to here. If you see the packet, so this is the source IP address, this is the destination, this is source MAC address, and destination is broadcast destination MAC address. Look at here, what happened for first time. Packet send to the hub. Hub send a packet to everyone in the network. And these two are drop the packet. And this is accept the packet. See, it accept the packet. Now it has to reply now. So again, it is sent to the hub. And what will happen? It broadcasts to other devices. Okay. It broadcasts to other devices. How many times you run? It keep broadcast. See, it is broadcasting always. Both send, receive. How many times it is pinging? It does not mind. It is broadcast the packet. Again, we'll try for other system from here to here. What happened? Packet sent to the hub. Hub broadcast the packet to the destination. Okay, the destination is going to reply the packet. So packet went to hub, again broadcast. Because it is always broadcast. That is a hub. It does not contains anything related to the MAC address or IP address recognition. So whenever it is received a packet, it's sent to the packet to all other devices. Got the point, guys?
Yes, sir.
We'll see that one again at the time of switch explanation. But here it is, something is happened. Where is my switch? Here is my switch. Okay. So there is another type of devices called a repeater. What is a repeater? So when you take this LAN cables, means the cat cables are there, no? These cat cables are support up to 100 meters only. Sometimes you have to connect it and communicating little more than 100 meters. So what happened? Okay, the cable is not supporting. Like a 70, 80 meters, signal strength will be reduces. 100 meters, more than 100 meters, you can't communicate. Generally, signal is strength will be reduces. So repeater repeat the signal. So then signal can send for longer distances. This is a repeater and this is a hub. Sometimes we can use a hub as a repeater and there is a repeater things also there. These repeaters, one side cable we are connecting here, another side will like a forward. See it is the signal is came stronger, then it is become weaker without closing completely weak. So we have some weak signal here. We put a repeater regenerate the signal as normal signal. Okay, as normal. How this actual signal is there, it go for that one. Not very high and the same as signal. It just repeat the signal. So then little bit extra distance we can able to communicate. Of course, you may not seen these repeaters nowadays, but we have an example for that one is Wi-Fi extenders. What is this Wi-Fi extender? See the Wi-Fi extender, what it will do when you have a device, your actual device is more distance from your Wi-Fi router. Your Wi-Fi router is here and your device is here. Near to the Wi-Fi router, you can receive a signal. Far from the Wi-Fi router, you won't get the signal. So in middle of it, you can see this path. This is the middle range. Not near, not very near to the Wi-Fi router, not very near to the device. It is somewhere installed. So this Wi-Fi extender receive a signal from Wi-Fi router and give it to the your Wi-Fi device, like a mobile phone, laptops, or maybe it is a TV kind of stuff. If it is in a different room or a different a distance place, we can use a Wi-Fi extender to get connected. Okay, just it is a bypasser. Originally, we are connected to our own Wi-Fi router only with its name and password. Only thing is to get a proper good signal, or maybe if you are in a no signal area, so with the help of this Wi-Fi extender, we can able to get reach to the signal. Okay, so it is Wi-Fi extender. If you have a doubts around like how this is working, go to the Wi-Fi extender, go to some YouTube videos, you can able to understand how it will be installed, the documents and all, you can try. Yes, understand what is a repeater? Repeater, repeat the signal. And example for a repeater nowadays is Wi-Fi extender. Understand how Wi-Fi extender works, where it is, we can able to place. Okay, these are all different Wi-Fi extenders. How to configure, where to place, all these things are available in a different details kind of stuff. We'll go to the switch. What is switch? Again, switch is also used for a LAN communication. Hub is used for LAN communication. Switch is also used for LAN communication. As per OSI, switch comes under layer 2 device. Switch is layer 2 device. Hub is layer 1 device. Switch is used for both small and large networks. Small and large networks. Hub is only for small networks. Switch can understand MAC address. It learns the MAC addresses of connected device. Switch learn the MAC addresses of connected device. Okay. It maintain the MAC address table. It maintain the MAC address table. It maintain the MAC address table. With the help of MAC address table, switch unique as the packets. Okay. Switch initially broadcast packets like a hub. Initially, switch broadcast the packets like a hub. Send packet to everyone. Broadcast means send a packet to everyone. Switch verifies the MAC address table against destination MAC address mapped to the port number. If it is find MAC address sent to the port means letter unique as. It is robotic explanation. Okay, guys. Sorry. People not minus, so no one is talking. That's why I'm explaining like that. Instead of explaining normal. I'm just reading and leaving. Okay. This is NIC, 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 NIC. And this is a ports like a port 1, port 2, port 3, port 4, port 5, port 6, port 7, port 8. Okay. So these are the different ports. For example, this is APC, BPC, C, D, E, F. This is a switch this time. What happened? Switch has a MAC address table. MAC address table. In the MAC address table, the table contains port number of switch, this switch port number and MAC address of connected device. MAC address of connected device. Okay, for example, port number 1, port number 2, 3, 4, 5, 6, 7, 8. These are the port numbers. Okay. So for example, first one is A wanted to send a packet to B. A to B communication. So first one is A to B communication. A send a packet to the B. So packet is going to the switch. And what is the source IP? Source is A's IP is source IP. A's MAC address is source MAC address. And destination is B. So B IP address is destination IP. B MAC address is destination MAC address. This is packet addressing. Just like you are writing a letter. If you are writing a letter, there is a to address and from address is there, no? To address is there, from address is there. So from address is source IP and source MAC address. To address is destination address means BIP and B's MAC address. Packet, it will check against to this MAC address table. Where is B's MAC address in this table? Where is the B's MAC address in the table? It didn't find. It does not contains B MAC address here. So what your switch is done? It broadcasts the packets to everyone in the network. Okay. Those who are connected will send a packet to everyone. Okay. And B accept the packet, remaining drop the packet. So meanwhile, what happened? Switch is also having MAC learning. It learn the MAC addresses of connected devices. So what it will do, the port number one, this is the port number one connected to a MAC address of A. MAC address of A's MAC address will display there. It learned already. Same way, same way, for example, as C is try to communicating to D. C send a packet to the port number 3. And where is the D's MAC address in this table? Not there. So then what it will do? It broadcast. It broadcast to everyone. Then what it will do? It learn the MAC address of C. Means port number 3 is connected to the C device with the C MAC address recognized by C MAC address. Like it. So when it is the systems are communicating each other, sometimes certain switches based on when you connect automatically using network discovery, so it try to understand. The fourth port with there is no connection. So we'll go to the fifth one. Fifth is connected to the MAC address. Six is connected to E device. Seventh is connected to F. So here it is, a MAC address table will be created when there are communicating each other. So the switch will learn based on the connected device, it learn the MAC address of the device. The MAC address table is created now. For example, I want to communicate from E to A, okay, or maybe E to C. I want to communicate from E to C. Packet is started from E, send it to the port number 6, and where is destination? C. But C's MAC address is my destination MAC address. Where is C? At port number 3. And it is go to the port number 3 like this. Okay. This is how it works. So look at here. Read it carefully. Thing. Okay. So what happened? A send a packet to B. Packet went to the switch. Switch does not know where is the B's location as per the MAC address table initially. Okay. Switch broadcast packet to every device like a hub. Switch learn MAC address of A and map to the port number 1 in the MAC address table. Okay. So like devices are communicating each other, the switch will learn the MAC addresses of the devices. Okay. When devices are communicating each other, now the packets are unicast. So switch initially broadcast packets like a hub, but it later it learn the MAC addresses of the devices. Okay, it learn the MAC address of devices and map it to the port number of switch. Okay. Which port number, which device, what is the MAC address? They will put it in a table called a MAC address table. With the help of this MAC address table, switch broadcast to the packet. Means A is want to send a packet to C. A want to send a packet to C. So what happened? Where is the C? It is port number 3. Then packet is sent to directly to the port number 3. No need to broadcast. This is about your this is about your switch. Auto delete it. Hub. Where there somewhere delete button is there. Delete. I deleted hub and I am kept keeping a switch for you. This is a normal Cisco switch. If you open, you can see number of ports also. Almost all 24 ports. Fast Ethernet ports are there. 2 gigabit Ethernet. 2 gigabit Ethernet for uplink purpose to connect router and get a internet purpose only. But mainly the fast Ethernet to connect a normal devices. So I'm connecting these devices already configured with an IP address. So just I'm connecting to the switch. Okay. This is the switch. Okay. And every PC has their having an IP address. Okay. So I'm going to use the simulation. Here is a packet from this PC to this PC. From here to here. Open it. See the source IP is 1.11. Destination is 1.13. Source MAC address, destination, so broadcast address. First, I send a packet to the switch. And it is broadcasting. As I said, first time it broadcasts. These two are drop the packet. Okay. So what I'm doing is in this one, show MAC address table. See it learned the MAC address of a device which is connected to port number 101. Which is the port number 101? This is F0 by 1. Okay. That is F0 by 1. See F0 by 1. And this is the PC. Check the MAC address. See the MAC address. Where is the MAC address? This is the MAC address of that PC0. And here, see the output. Is it both are same MAC addresses? 00D0, 00D0, D3C5, D3C5, EEDC. See it is? Both are same MAC addresses or not? And it is showing only one MAC address here and one port because of only one transaction is happened till now from here to here. Guys, okay, have you seen that one? MAC address?
Yes, sir.
Very good. Now this packet is traveling to this one. So what is the source and destination? This is source. Now this is destination when it is replying. Source is 13, destination is 1.11. 1.11 MAC address. This MAC address is available under this. This is the MAC address, and where it is the MAC address is port number 1. So no need of broadcast, but we'll try. Cities directly reach to the destination. When you remember, if you remember the if you remember this, what we can say, hub for sending it is broadcast. When receiving time also it is broadcast, right? So if you are sending A to B, broadcast. B to A, broadcast. Okay. So one more. This is check it now. This is the MAC address, a device MAC address which is connected to port number 3. Port number 3. Now it is okay. Who is 3? This is a 3. Okay. This is 3. And this is the device. Go to device, check the MAC address. This is the MAC address. Check it as per the MAC address table. See the MAC address table. 0005 5E 3B C7 AE. Okay. So it learn the MAC addresses when devices are communicating to them. So again, I do some more packet kind of stuff from here to this communication, from here to here. See, first time this MAC address is not available. So it broadcast. Okay, it broadcast, and our switch is learn the MAC address of this device. Sorry, there is a mistake. Okay, this is the MAC address. It is learn when it is send a packet. When it is sending a packet, it will learn this device MAC address. But it is unicast because this MAC address is available in this switch at unicast. So initially broadcast, later unicast. Now to send a packet from here to here. See, there is a broadcast or unicast. It is do broadcast, don't worry, and it is do unicast. Just that's the ARP protocol has to be resolved. That's why I am doing like this. Okay, it done multiple times of communication. See now, this packet I want to send to this first time communication. No, 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 not like this. Now try again from here to here, packet send and unicast. Reply unicast. So initially it broadcasts the packets when initially it broadcasts the packets like a hub, but once it is learned the MAC address table, it unicasts the packets. It means what is the destination based on the destination MAC address, based on which port it is they showing in the MAC address table, packet will be forward directly to it. Okay. Device connected to first port. Device connected to another destination is connected to port number 3. Source is connected to port number 1. Destination connected to port number 3. So source send a packet. Destination directly to go to the port number 3. Okay. So packets went to the switch. Switch does not know about B. Already I told this one, right? Okay. Guys, understand broadcast and unicast how it will do. Understand the difference between hub and switches?
Yes, sir.
Very Okay, switch again. Switch is used for LAN communication, and hub is also used for LAN communication. But hub is small networks, switch is for both large and small networks and large networks based on the number of ports are available. Also, that is a one advantage of switch. Okay, hub broadcasts the packets to every device connected to the hub. To every device connected to the hub, it broadcasts the packets, and it always broadcasts the packets. But switch is not like that. Switch initially broadcasts the packets, but while devices are communicating each other, the switch learn the MAC addresses of connected device, switch learn the MAC addresses of connected device, and create a MAC address and create MAC address table. With the help of MAC address table, the switch forward the packets to the particular port like a unicast. Okay, so initially it is broadcast, but once it is created a MAC address table, with the help of MAC address table, it unicast the packet, means it directly send to the destination device instead of broadcasting. Switch send a packet to the destination directly. Okay, so switch is layer 2 device, hub is layer 1 device. And as I said, switch is layer 2 device. But someone will ask, like once you are into some networking person, you met any networking person, you said a switch is layer 2 device, but I have working with layer 3 switches. Okay. So of course, there is a layer 3 switches also there, guys. But difference is layer 2 switches do not work with the IP addresses. But layer 3 switches work with an IP addresses, inter VLAN routing, VTP kind of stuff. Layer 2 switches don't do direct inter VLAN routing kind of stuff. It is to function as a router and as well as switch. Layer 3 switches are work as a switch as well as a router, but no WAN connectivity. But router having WAN connectivity, switch don't have any WAN. It is used for inter VLAN routing kind of concept. Switch function based on the MAC address learning, forwarding kind of stuff. Okay. There is a cut through switches, store and forward types of switches also available. And because of this unicast, lesser the collisions, lesser the packet loss. That's we can able to use for a multiple devices also. Works based on unicast and floating. Guys, switch is important, hub is important. Difference between hub and switch is very important. Okay. Then we'll go for the router. What is a router? Inter-networking device. Inter-networking device. When you have a different networks, all are different LAN networks, you want to make a connect and communicate between these different networks, we need a router. Router is used for a inter-networking. It connect to our more networks. It make a communication between different networks. So router works with a logical address. Switch works with a physical address, MAC address. It create a MAC address table. But router works with a logical addressing. Two things of router is there. One is understand and connect to the different logical networks. Router is used for a connecting different logical networks. Okay. Also, there is a packet paths kind of stuff. So that's will see. Okay, router is layer 3 device. Hub is layer 1 device, switch is layer 2 device, router is layer 3 device. It's a comes under network layer. It works with a logical addressing and routed protocols and routing protocols also. Okay, we'll see that routing protocols. You can use it to connect to or more different networks. See, this is a one network, this is another network, this is another network. With the help of these routers, we can able to connect them and communicate between them with a WAN connectivity. Okay. The route means path. Router means It shows best path to reach the destination. For example, I want to reach google.com. I want to reach google.com. How I reach my google.com? So simple put a trace rt www.google.com. So it will tell, are you able to reach the destination? It's not that one, it is how you reach the destination. From my PC to my default gateway. From my default gateway to my ISP and ISP routers in between and some other routers. Finally, I will reach the destination. Don't worry, just I will try. Within a 30 hops, you will be able to reach the destination. See it is showing different IP addresses. Those are nothing but a different routers IP address, which is outside of my network. First of all, from my system, I have to reach my gateway. From that one, ISP network, and then different other networks in this world, then finally reach the destination. This is how I reach to my destination. From my PC to my destination, this is the path to reach the destination. How I'm getting this path? Who will tell this path to reach this destination? For example, from your home to the railway station or a bus stop, okay, main bus stop or by main railway station you want to go, it can have some several routes are there, right? Which route is better? Faster you can able to reach, or maybe less traffic. Okay, so like that, broad roads, highway road kind of stuff, which is better. So that will be given by the routers. So the router is make a connect and communicate between different networks. It is internetworking device. Router is internetworking device. It's a layer 3 device as per OSA layer 3 network layer only. It works with both LAN and WAN communication. Okay. OS it is works with a logical addressing and routing concepts. As I said, guys, route means path. Router shows best path to reach the destination. Routers use routing tables to know how to reach the destination. Inside of these routers, there is a routing tables. With the help of routing tables, the router will tell you how to reach the destination. With the help of routing tables, it will tell can you reach the destination or not. Okay. Think like this is a network and you want to communicate outside of your network, you have to connect to outside. This is a small router it is. Yeah, sorry, there is a switch. So as I said, from here to here we use from Ethernet to this one because it is the main connectivity. So this is one network. Okay. If this PC want to communicate from here to here, we don't require this. But you this PC want to communicate outside of the network, we need it. Yeah. So I am not going to configure. Okay. Yeah, just for fun. Okay. I currently I do not have. I think I have. 1 second, guys. Open. Not in saves in your D drive. CNA practicals. No, not this one. This is the good one. See, this is one LAN network. This is another LAN network. This is another LAN network. I want to reach from this to this. How can I reach? So I have go to simulation mode, then go from here. See, packet 1 to, yeah, it is gone directly. So no, 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 sorry. There is a mistake happens. Packet has to be traveled from here to here. Then it is went to the switch and switch to the router. Okay, the router will tell you this path means it has to go like this, then this one and this one. No, no route. Maybe I didn't implement. Now it is reaching. See this. Finally reach the destination. Okay, yeah. So down it is reach the destination. Okay, it is reach the destination. Again, it return journey. Why it has happened? Yeah, now it is return journey. Okay, so failing. Why it is failing? I have to check it once. I think I didn't configure properly. Show routing. Yeah, it is. See, this is called a routing table. It is configured one, but I didn't know. But it is. This is a D. It is showing, right? So this is D means EIGRP. Okay. This is a routing table from this router. Okay. It is saying that if you want to communicate to this network and you have to go to this, you have to go like this. If you want to communicate to this network, you have to go like this. You have to want to communicate to this network, you have to go like this. If you want to communicate to this network, you have to go like this. It means you want to communicate from this PC to this PC, you have to travel the packet from here to here, here to here, here to here, and then here. If you want to reach here, you have to travel from like this. You want to reach from here to here. So sorry, better I will this full screen snip. See it is. If I want to reach from here to here, how to go? This is switch to the router. This is my gateway. This is first. Then I have to go to this and this. Then reach here. Okay. For example, I want to reach from here to here. First, I have to go to this. Okay. From here to here and there to here. Okay. So in the world, there is several routers are there. So these routers having a routing table. Okay. These routers having a routing table These routing tables will tell how to reach the destination. These routing tables will tell how to reach the destination. Okay. These routing tables will tell how to reach destination. If you see clearly, if you want to reach this network, you have to go to this one. This is R2. This is R2. You want to reach this network, you have to go like this. Okay. It will tell the destination. Okay. What are the routing tables? How these routing tables are created? Either you can configure manually, but it is very difficult in the bigger networks. So you can use dynamic routing protocols like RIP, EIGRP, OSPF, like that. Here I use EIGRP routing. I use EIGRP routing protocol to create routing tables. With the help of routing tables, the router will tell you how to reach the destination and best path to reach the destination. How to reach the destination, best path to reach the destination. So 3.11, and see, this is different network. Yeah, we are not at up to IP address. It's 1.11. I'm in a simulation mode. Sorry, real mode. So I can able to reach 3.11 from here to here. I can able to reach. But what is this trace RT? It will tell how we have reached the destination. See, first one is this one, 192.168.1.1. That is my router address. Router to this hop. Okay, this is 11.0.0.2. Then 12.0.0.2. This one. Then 13.0.0.2. This one. Then finally it is reach this one. See, this is the trace RT. How you reach the destination. Let's understand what is the router. Router is internetworking device. It connects two or more different networks. Okay, router used for both LAN and WAN communication. Router used to connect two or more networks. Router understand and works with this logical addressing means IP addressing. Router is a layer 3 device network layer. Router will show best path to reach the destination. Okay. So router uses routing tables. The routing tables, it uses routing tables to know how to reach the destination. To know how to reach the destination. These routing tables are created manually called static routing, or these routing tables created automatically by using routing protocols called dynamic routing. Okay. There's a dynamic routing protocols called RIP, AIGRP, OSPF. With the help of these dynamic routing protocols, router generates the routing tables. With the help of routing tables, router will tell you how to reach the destination. To check how you reach the destination, you can use a command called trace RT. Guys, understand what is a router, what is switch, what is hub.
Yes, sir.
Very good.
Yes, sir.
The last one is modem. In the devices, the last one is modem. What is a modem? Modulator and demodulator. Modulator and demodulator. If you are from CSC, not CSC, ECE background, you understand FM radio, AM radio kind of stuff. Everybody understand FM radio, AM radio, but modulator and demodulator, the words are in ECE people only. ECE, ENTC people only. Okay. So you want to transfer a signal from one place to another place. okay, via certain medium. So we have to convert the signal based on that medium related signal. And so that is a modulator. To send, we modulate and send. At receiving it, we demodulate and receive it. Okay, where it is because of in modulation, it's a different form, and you demodulate and we will accept. In our network, guys, in our local area network, all the signals are in the digital form of signals. Means that's pulse signal type of things. But when you are sending a signal, when you are sending your packet outside of your network, so it is different ways you have to. So sometimes telephone cables you have to send. Sometimes it may be a fiber optic cables, depends upon your network. It can be a telephone cable or it can be a fiber optical cables. So Modem makes you connected to ISP using telephone cable or a fiber optical cables. I think I missed these pictures. Otherwise, I will keep it. Okay. Modem makes you to connect with the fiber optical cables or a um, telephone cable. See, this is fiber optical modem. From ISP, there is a fiber optical cable give to the modem. From the modem, we are connected to our router. From router to our system. Okay. So like that, the modem use it to connect you to the ISP via fiber optic cable or telephone cables. Okay. So what is the purpose of modem? To connect internet. What is the purpose of modem? Is to connect internet via ISP. Okay. Some Wi-Fi routers has a built-in modems. Some Wi-Fi routers has a built-in modems. Some Wi-Fi routers don't have built-in modem. Then you have to use separate modems to connect to the ISPs. Okay, guys. What is the purpose of modem? I think I didn't explain this. I'll explain now this one. This is a very starting one. Okay, entire pictures are disturbed. Just copy and post. Just no problem if it is repeated. So guys, look at here. Small office, home office. Here is a hub bar switch is connected to the devices. So this is a LAN network. And this is a wireless access point is a device used to connect these devices to create a wireless network. Simple. It is. I have to open one more Cisco packet tracer. 2 can we open or not? We don't know. In the olden days, we can able to open. That is, we can able to. So they are given all our IoT kind of stuff only. Mhm. This is wireless. It is wireless router. And to connect to the wireless router, we need a wireless devices like a laptops. Okay. And this is my wireless access point. If you see, this side is a WAN port and remaining a LAN port. This is wireless kind of stuff. You can configure it. You can give the display name of your wireless access point and then configure the WAN connectivities and then LAN connectivity and wireless connectivity. Just I will try to configure the SSID. My SSID is um, 7net. Okay, and authentication is disabled, but I will give some authentication. So no problem. So this is some authentication, and I'm giving a password admin123. Okay, only Wi-Fi, just like a wireless access. Yeah, only that setup I'm giving. Okay, so what will happen to this? So from here I have to connect, right? So this is also built-in Wi-Fi kind of stuff. Configure and to showing fast Ethernet. So we need a PC wireless. It's not connecting. This is wireless. IP config. So we need an adapter. It is having a wireless adapter. Now it is having wireless adapter. Desktop, wireless, Wi-Fi, connect, refresh. Now it is see 7net, connect, give the password, admin 123. Connect it. So this is I got established connectivity between my laptop and my wireless router. It is only wireless access point. It means it is I didn't connect any internet to it. Okay. So I created a simple. I connected a simple display. Connect. Give the password. So I connected a. I created simple. What we can say. I connected. It is showing connected. Connect. Password. Connect. Wait for yeah. It is connected now. And itself like you will get an IP address from DHCP. Okay. So this is wireless network. Okay. It's a WLAN network. So this is wireless network. This is wide network. But you want to connect and communicate outside of the communication. Okay. So you want a what is it is from here to here. From here to here, you want to communicate. You can communicate from here to here. You can communicate from here to here. Okay. So this is a LAN. You can communicate each other. This is WLAN. You can communicate each other. If they have a common interface between them, they can also communicate each other. But if it is want to communicate outside of the network, what is the required? What is the requirement? Is a router and modem. Modem makes you to connect it to the internet via ISP using telephone cable or fiber optical cable. The router, when you are connected to the internet, this is different network, this is different network. So Okay. So then, okay, this router makes a connected between these two networks. Okay. Let's clear my notations. Sorry. Okay. Here it is. Hub and switches for wide LAN communication purpose, wireless access point to connect wireless devices to create WLAN network means wireless LAN network. Router is internetworking device which is used for both LAN and WAN communication. Modem used to connect to the ISP through the telephone cable or fiber optic cable for internet. ISP means Internet Service Provider. You may get a doubt, sir. I do not have hub, switches, wireless access point, routers, and modems, but still I am getting internet because your home Wi-Fi router is act like a modem, router, wireless access point, and hub and switches. Okay, so it is sometimes it can be integrated inside, sometimes it is not integrated inside the modem. Okay, so but whatever it is usually in our home. It is modem, router, wireless access point, hub and switches are integrated into one single Wi-Fi router. That's the point. What I'm trying to say. Nothing. Okay. So what is the next point after this? We'll check it. So we completed networking devices. Next one is actually IP addresses. Okay, so we'll see. And there I have put in some networking commands, but I will tell these networking commands separately. Okay, we am going to start with the IP address after the break.